Hello and welcome everyone to our latest webinar. We're just waiting for a few more people to join in and we can start then right away. Okay, cool. I see that quite a few people have joined. I think more people will keep joining in. So let's get started. I just wanted to give you all a few ground rules and a few house rules basically that we'll have during the webinar. If you can switch to the next slide. So yeah, so this session is being recorded for all of you to know. So you will get a recording of this session. We'll also share a PDF version of the presentation, so you can go through that. We are using the Zoom Q&A for asking questions today. So please leave your questions as you have them in the Q&A section, and we'll try to take them as soon as possible, mostly during the end of Thomas's talk. And we'll have a survey at the end of the webinar. So this is super important for us to keep improving. The previous ones have been very helpful. So if you close the session here at the end of the webinar, please do leave feedback for us. That really helps. And with that note, I wanted to invite Thomas, our speaker for today. Thomas, could you come online and just introduce yourself and the topic that you have for us today?
Yeah, thank you very much, Pari. So yeah, I'm Thomas. I hope you can hear me.
It's very clear. Yeah, sounds good.
Pronounced. Yeah. So short for me, I'm open source engineer at deepset, and yeah, for quite a while now I've been dealing with evaluation of semantic search systems, and of course also here. The evaluation of LLMs is not far. So today we'll dive into LLM hallucinations, and especially in the context of retrieval-augmented generative question answering. So how to detect them in retrieval-augmented generative QA will be the question for today. To give you a brief overview, what is the plan for today? So first, we will look into hallucinations and, of course, why they are a problem of today's LLM-based systems. Afterwards, we give a short introduction into retrieval augmentation and, yeah, basically see why this is a tool to mitigate hallucinations, but not to completely avoid them. And in part 3, we elaborate on possibilities of detecting hallucinations. So this is basically the main part of this talk, where it gets very interesting, I hope. And in part 4, we close this talk with a brief outlook, what we can do beyond just detecting hallucinations. So I guess all of you have already seen an example like this in the past when dealing with LLM-based systems. You ask a question, for example, here, did SVB, so the Silicon Valley Bank, collapse? And you get a result, no, SVB did not collapse. So this is a very prominent example. We call this hallucination because the system responds with obviously an answer that is not true. And this can be, like in this case, due to the fact that the event occurred after the training data was collected for training such a huge LLM. But we will see in a minute that there are various ways to provoke these hallucinations. So it's not just about mirror events. Of course, for this, we can also train this new data into the model, which could be expensive, but there would be ways around it. In the end, what we can state here is that even if the model is wrong, it is always very confident. So we see no, SVB did not collapse. So, and this is sometimes a bit too confident, right? So we all know this particular example of overconfidence. So think also about use cases like we have, for example, with our customers. Think about a legal assistant that produces such wrong answers, say gives wrong advices that lead to problems, that lead to a certain loss of revenue. So this can be quite a problem with these hallucinations. Another example would be a online newspaper. Say you want to create articles and get background news on certain topics, people, or events, and you get wrong information, and these wrong information make it into the article. This clearly undermines the reputation of your newspaper, right? So in these cases, it's very important that the information is not only correct, but also transparent and verifiable. So another thing that we can do with LLM-based systems, especially in retrieval-augmented setup, we'll come to that in a minute, but we can request citations. So with retrieval augmentation, we can basically define the documents that the LLM should produce an answer from, and then say, okay, please cite the documents that you based these answers from. This is an example, for example, here, what is a frittata? And now you can look at these answers. You see those squared brackets that are citations. And now a question for you would be, so look at these 5 sentences. Do you see some hallucination? I give you one hint. One sentence of them is actually a hallucination. To conclude this, even if you looked at it for hours, you will find it very, very hard to determine which one of them is a hallucination if you do not know which data went into the model. And citations help, we can conclude, but also, are they real? Because to give you the conclusion of this puzzle, sentence number 3 was the hallucination here. So even with the citation here, number 2 should be the cited document. We get like a super confident answer here, even with citation, although it's not true. So to sum this part up about hallucinations, hallucinations can undermine the user's trust into your product, as we saw. And it's super hard for humans to detect hallucinations without tools, even in retrieval-augmented setup. And so far, it doesn't look like there's a cure for LLM hallucinations inside. So models tend to have this urge to complete, even if they don't know the relevant information. So they will always give you something. And it's also about how these models are trained, that we can see that there's like an intrinsic problem with hallucinations in those models. What we can state, however, is that we can mitigate, but not avoid hallucinations. And for this, we go to the next section. But first, let's conclude it like this. Hallucinations are one of the most important challenges for using LLMs in production use cases. So now, how to mitigate those hallucinations? One of the most promising approaches is retrieval augmentation. So how does that work? First, we need to start with a normal LLM request. So we basically have a question, like in the first example, did SVB collapse? This question will be translated into a prompt. So a prompt consists of an instruction, like answer the question, and a placeholder where we insert the query. So did SVB collapse? This is then basically just rendered into text, which we can feed into the LLM. And the LLM will spit out an answer, like in the first case, no. So what can we do about it? We can introduce a retriever which connects to a external data source. So what is this? What happens here? We start the same way. We have a question. We feed the question into the retriever. You can imagine a retriever like a search engine. The retriever selects the documents that have the highest probability to answer this question. So we get back a bunch of documents, say 5 documents or 3 documents, and also feed them into our prompt. So when we render our prompt, we not only have the instruction, answer the question based on the context and the query with the question, but we also have the document text. And this we feed into the LLM and then hopefully get the right answer, like yes. And how such a prompt can look like, we can see here. So here I selected the document with the relevant information from the Wikipedia page about SVB. For example, here in March 2023, blah, 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 which led to its collapse and seizure on March 10th. So based on this information, it's way easier for the model to correctly answer this question. And this is basically what we mean by retrieval augmentation. Retrieval augmentation also has some nice advantages. So we can implement further mitigations. We can tell the system inside of a prompt. So you can imagine this like a prompt template to grant not to answer. So if the document does not contain the answer to the question, please say it is not possible given the available information. And that already improves our system. Another thing that we can do is what we saw in the second introductory example. So we can add citations. We can just instruct the model to please cite the documents using this pattern, document, square bracket, number, notation. If there are multiple documents containing the answer, blah, blah, blah. And then we get actually citations in this particular format. So now we saw what retrieval augmentation is and how it helps to mitigate at least parts of hallucinations. So it can mitigate hallucinations if we provide the right documents. But it can't fully avoid hallucinations altogether. As we saw in the second example in the introduction, even with citations, we can see hallucinations in retrieval augmentation. It also allows for further mitigation techniques like citations. And we have this advantage that we know exactly which data was used to generate the answer. So we always know the documents that we fed into the model. So retrieval augmentation is the most promising way to get truthful and verifiable answers from LLMs. But now let's look a bit more into those citations. So in the past, we found some very interesting papers about this. One of them is this, evaluating verifiability in generative search engines from Stanford, which basically looked into the citations that generative web search engines like the new Bing generate, for example. And they annotated those citations and wanted to know how good are they? Are they precise? How many sentences have actually citations? How good are they? And what they found out is quite, not so good, I would say. They found that 51.5% of the generated sentences have actually citations, and only 74.5% of these references fully support the corresponding statement. So in more than 25%, the statement was not fully supported or not at all supported. And that's quite alarming. So these citations or these references that those models create are not super reliable currently. Also, what they found out, what is super interesting is that responses that are fluent and appear more helpful often have lower citation recall and precision. So on the left side, you can see this correlation between citation precision and perceived utility. So the labelers were instructed to also mark each answers with a utility score, I think from 0 to 5. And they found an almost perfect negative correlation between the precision of citations, so how much of them that were given are actually true, and the perceived utility, which is even more alarming. So citations are far from perfect. Another paper that I want to show you is this one, which is quite interesting. So automatic evaluation of attribution by large language models from the Ohio State University. And what they basically did, they tried to automate the detection of citation precision, more or less. So what they did is they also went over all the citations of such systems, of retrieval-augmented systems, and labeled each of them as either attributable, extrapolatory, or contradictory. So that means extrapolatory means that it's not fully supported or not at all supported, and contradictory means there's a contradiction. So the source document actually states something, which some contradiction with regards to the answer statement. And what they also did is they fine-tuned a range of models on the task. And they found that a Flunkey 5 model that they fine-tuned themselves outperformed a few-shot ChatGPT setup. So they built this attribution score models. And in the end, but we have to say, it didn't work that well. So we had like a F1 micro score of 65%, which is not that great. But they showed it's hard, but it's not impossible. And we took that up and also looked into the data set they provided, which is pretty nice. And from the previous paper, they also provided some data set. And we looked into that and thought, okay, how can we use that to actually not only detect citations, but also hallucinations, even if we don't have any citations. And that's then basically my next part that I want to give you a hint here. So do we even need citations to assess whether it's a hallucination or not? So what they did basically was this in this Ohio State paper. They built a model in which you can feed a answer sentence, such as deepset was founded in 2018. And they knew the citation, so they knew from which document it came from. This is depicted here by this in June 2018, blah, blah, blah. And just by feeding these two things, and I guess the query into the model, they got basically this classification out. I simplified it a bit to just give like a score, which says is it attributable or not. And in this case, we would get for this example 97%. For the second sentence, products of deepset are hasted farm and OpenSearch, which is obviously not true because OpenSearch is not a product of deepset. We would also have the citations, so the references to the documents that are cited here. In July 2019, the company released the initial version of OpenSearch Farm, and here also Haystack. So we at least have some partial support for Haystack and Farm. So we would expect a score like this, 62%, or in the range, in the ballpark, of course. And the third document here would be with its modular building blocks, blah, blah, blah. And here at some point, OpenSearch is mentioned, but in a completely different context than we have in this answer claim sentence. And we would expect it to be super low. So basically the model that they created is not really bound on citations. So what you can basically do is this. If you know in retrieval augmentation, you basically know each document that we fed into the model. And so what we can do is we can calculate the score for each of those documents that we initially fed into the model. And then we would expect something like this. So we have those 3 documents, say we fed them into the model, and we will get for the first sentence like a very high score for this first one and very low scores for the second and third document. And of course, the same values for the second sentence. But now we also feed in the first document, and we would expect a very, very low score here. So this is basically our idea on how the hallucination problem could be solved. All we need is basically such a model or a framework that can detect hallucinations, attribute a score to it. And so we looked into the literature, what is out there. So we know this paper from Ohio State, who tried some approaches to train some models. But if you look into the literature, there's more. And there's a ton of research going on in this very topic. But what we can conclude here and sum up is that all of these approaches we can classify into either it's like human assessment, so humans actually try to assess whether it's a hallucination or not. Then word overlap metrics are used a lot. We'll come to that in a second. Hallucination detection models, which we will focus on the remaining part of this talk, and also self-reflection. So what we mean by self-reflection, it won't be covered in this talk here, is that we basically take the answer and feed it back into the LLM and ask, okay, is this answer grounded on the documents? This has, it's super interesting, but it has some disadvantages. So first, we need to issue a second request because we first need to get the answer and then feed it back into the model together with the whole documents that we already got. So the request is also pretty big. So at least we would end up with higher latency and also like increased costs because we have to do another request. Problem here also is that in the literature, there's nothing currently that evaluated that. So we cannot really say, is it like a good approach? Is it bad? We just don't know. So we focus on this hallucination detection models, as we already saw also from this Ohio State paper, that it's technically possible. But first, let's look a bit into human assessment. We also thought about this, can we maybe implement something that we as humans, if we create like a new system and we have a feedback function, can we use the data in some way to detect hallucinations also? What we found is that it's quite difficult first to get a really good data set that can depict whether it's a hallucination in the retrieval augmented setting, because we always need the passages, so the documents that we fed into the model, the answer, and of course the query. And by trying out some labelings, we found out that it's quite expensive. So we made about 30 samples per hour, which is pretty slow. And we also found that we need really, really good annotation guidelines for this. So language is so super fuzzy that in the first few examples, we found so many edge cases on which we had to think and find rules, how to handle this. It's really, really difficult. And I think I don't need to say that also here we always have the answer of one model, so it doesn't scale well with new models. So for each new model, you would basically have additional labelers that have to annotate it. But we tried a bit, and we created such a data set because we thought these data sets that we already have from those papers were always lacking like the full input of documents that we fed into the model. And that's a problem. So we created this data set, and now we are using it to assess automatic hallucination detection. And we will look into this in a few seconds. But first, let's look briefly into word overlap metrics. I guess all of you might have seen that. So what is this? Bleu, rouge, meteor scores. So basically, we take the raw representations as like words and build n-grams and just see how big is the overlap of these words from the answer to the source document. So I made an example here. The amount of dairy used in a frittata should be carefully measured, as too much will make it too loose and too little will miss out on the desired creaminess. So everything in green we will also find in the source, but anything else has no representational overlap. So anything that is rephrased or semantically similar but syntactically different words won't be recognized. So we have some natural limits with these approaches. So limitations are just too big. There might be edge cases where it could be promising to use it, for example, if we want to rely on exact dates, but then also string matching might also be okay. But what we focus on is hallucination detection models. And look at this. This guy is back, Bert. So we looked a bit into Bert score. What does Bert score do? So Bert score is the framework to extract embeddings and score the semantic overlap between sentences. So basically exactly what we are more or less looking for when we want to assess whether an answer is attributable to a source or not. So you can imagine it like this picture on the left side. So on the y-axis, so on the left, we have all the tokens of the answer, so all the words of the answer. And in the bottom, we have all the words of the source document. And now we can calculate those semantic vectors for each of these words and calculate the similarity, simple cosine similarity between them. And what you can see here is in the darker parts, we see a high semantic overlap. And in the lighter parts, there's no semantic overlap. And this information is super valuable if we want to assess attributability of the answer. For example, you can see here these diagonal patterns. These typically show similar expressions, or sometimes also the model copied parts of the text from the source into the answer. And then we can see, okay, these dark diagonals show very, very high overlap. And what we did is we tweaked this Bert score a bit. So we changed a bit how now these attributable scores on token levels, on word levels are calculated, because you can take this matrix and then, for example, just for each of the answer tokens, take the maximum out of all the source tokens, and you will end up with an array of numbers which have these ratings. Then you can mean it normally. That's how you calculate the Bert score, and we tweak that a bit to get like a better representation. And what we basically found is that with this approach, we can already outperform the best model of this Ohio State paper on their data set, which is quite nice. And we didn't stop there, but also trained a deburter large model based on some data sets that also those guys from this paper used. And now in the end, we get a performance bump in F1 micro of more than 10% points, which is pretty nice. And what's also important here to take in mind is the model size. So the best model of the paper was a Flam T5 large, which had 770 million parameters. So with an off-the-shelf Bert score model, it's not even the best model in Bert score. If you look into the docs, they recommend a deburter, but still Roberta large is the default model. And this already outperformed it, and it's only 330 million parameters big. The self-trained deburter large model is 435 million parameters big. What's also interesting, or what's important when it comes to practical uses of this approach is, as we can see here, this contradictory class, it doesn't work very well. This is one thing. And also when it comes to say, okay, what do we do differently for contradictions than for this extrapolatory section? Well, both are basically hallucinations and we don't want to have them. That's what we know. So one approach could be to just merge those classes. And when we do this, we already get like an F1 micro of beyond 80%, which is not bad. And now that we have that, we can raise the questions, okay, what can we do with it? So now that we can obviously detect hallucinations, what does it give us? So one obvious idea would be to visualize it. So say we have here in DeepSet Cloud a question, the question from the second example in the introduction, what is a frittata? Then we can basically, after the answer has been generated, we can run it through our model, through our hallucination detection model, and add a score to each of the sentences that depicts whether it's a hallucination or not, and then we can visualize it. And this already gives us like a super powerful idea what could be possible with this. Now we could do with this one sentence that is not grounded in the source documents, we could either throw it away or add a warning to users, hey, this might not be grounded. We can even, for all of these grounded sentences, we know exactly from which document they are grounded. So we can add citations, but for each of the sentences. And we can add links to the documents to actually jump there. If you look into Bert score also, as we have the data on a token level, we could even think about jumping into specific passages of the documents to say, okay, there's the attribution coming from. So I guess you get the idea that in the end, this could be super powerful. So to sum this up a bit, what we saw now is that hallucinations are one of the biggest challenges for running LLM-based systems in production, especially when you rely on the user's trust and wrong information and intransparent informations are no-goes. Retrieval augmentation and the right prompt can mitigate but not avoid this problem. We saw examples for hallucinations when using retrieval augmentation. And we showed that automatic detection of hallucinations really as a cornerstone of improving LLM-based systems is possible. And now we can think not only about applying such a model, such a hallucination detection model, after we ran a prompt. But we can, say, train different models. Say you have a problem with hate speech, then we can train a model for detecting hate speech and also apply this after you got the answer from your LLM-based systems. So using those models on top of the output of LLMs helps to create, true observability. So we can also track over time, see, does the hallucination increase over time when we are running a retrieval-augmented pipeline. So as a conclusion, detecting hallucinations here is just a starting point. I think that adding all those models on top and then measuring how good the pipelines perform over time is really, really powerful. And with this, I want to conclude here and just give one last hint. So if you like, of course, and you haven't done it before, of course, we always like if you join the Haystack community, create issues, or contribute to our code. And of course, you can look into our deepset cloud offering, SaaS offering. I have the links here. And now we go back to Pari.
Thanks a lot, Thomas. I had to unmute myself there. So I mean, thank you so much for the session. We do have a lot of questions and a lot of like really long ones as well. So I'll spend some time reading them out to you. Maybe we start off with like a straightforward one. This is by Dvijesh Bhatt. So he says, like, sometimes even after the retrieval process, the LLM model continues to hallucinate. So how can we prevent this from happening?
So yeah, as we saw, even with retrieval augmentation, always when the model generates something, currently there's nothing to prevent hallucinations, I guess. All we can do is apply such a model and see, okay, on a, say, sentence level or even token level, is it attributable to the sources? Because we know the sources. And then afterwards, it's more or less like a engineering decision or a product decision what we do with it. If we detect a hallucination, we could even try to feed this back into the model, say, hey, this is a hallucination, please give me a different sentence. This would also be an opportunity.
Got it. So then there's a question by John Dema. So he says, would it show multiple source citations? So for instance, if part of the answer was supported by the content in 20 different documents, would it just choose one document, or could you see all of the source sites?
So basically what we would get is for each of the source document, we would get a score. And then it's basically also, again, like an engineering task, how to aggregate it. So you could basically say, okay, anything that has a high score gets a citation. This is totally valid because we can see in various examples that sometimes sentences are supported by multiple source documents. So yes.
Yeah. And then there's also a follow-up question from John as well. And so he says, like, and what if the source content contained contradictory answers? If there is content in the source document that says a frittata is a tropical parrot and the other document describes it as a dish, it wouldn't technically be a hallucination, right? But could it still result in an incorrect answer? That's the follow-up.
That's a good question. Yeah. To be honest, I would expect it to be at least we would see some grounding, definitely. That's definitely a tough one. So I'm not sure. I think here the better measure would be to avoid actually contradicting documents inside of your document store. But I know that's not always possible. But that would be a very interesting edge case that might need a bit more engineering.
Cool. So there's this question from Sonam Gupta that came in like towards the very first part of the presentation. So here's the long version, right? So she says, do you believe reinforced learning from human feedback can be a fix for LLM hallucinations? So do you think LLM hallucinations occur due to auto-regressive nature of LLMs? Which I checked with Julian in the backend, and then he said like this can also translate well into, can we train models not to hallucinate, basically?
Yeah. So my personal belief is, yeah, that it's like a inherent property of these models. And as I stated, currently I don't see anything inside that we just on by different training of these models that we can stop them from hallucinating. We can improve prompts. We can feed in documents for retrieval augmentation. We can state it in different phrases that we just want to get the answer based on this documents. But these models find ways around it. So I think, yeah, it's an inherent property, and I don't think that with training alone we can manage it. Of course, we can improve it at some point, but to fully avoid it, I think it's just the nature of these models to always have this urge for completion. So they always generate text.
Awesome. So then we have a two-part question from Anila Mendoza here. So I'm going to read both of them. So she says like retrieval augmentation is another way to fact check, right? So question mark. Or is detecting hallucination the start to fact checking, that is for news information, etc.?
I think retrieval augmentation is definitely one way to at least know which the answer should be based on. But as we saw, even then we can have hallucinations, and we cannot be sure that it's that the information is just coming from those documents that we fed into the model. Second question, detecting hallucination as the start to fact check. I'm not sure. I think it's not the start to fact check, but it eases it a lot. You know, you could basically, with a retrieval augmented setup, you could just go over all the documents that went into the model, you know, which documents that are, and compare them manually to your answer. Then you would also be totally, it would be totally possible to fact check, but it would be very, very, difficult for you and time consuming. And I think such a hallucination detection model it does ease that very much. Yeah. So.
Got it. Then the question by Christian next, right? So what about we ask the model to generate SQL queries based on a described table and so on? So how can this case be covered? I've seen multiple cases where query is correct, and when the columns are inverted, the query malformed, etc. So for example, show me like top 10 users that have done this and that in the past week. Is this clear for you? Like
I think I get what is the point here, but I think it's not related to retrieval augmentation, because here, basically we do not have anything to which we can compare the answer, right? So in these settings, it's really, really difficult. Whenever we go out of this retrieval augmented context, it's super, super difficult to assess whether there's a hallucination or not, because we have nothing to compare about. Technically, we would need to look into the whole training data that has been used for the model, which probably is not a good idea.
Okay, there's a bunch more here. So I'm gonna go with one. So another question was like, in our experience, how often does hallucination occur in retrieval augmentation? So how big is this problem?
So from our data set, let me quickly look into it. How much we had here. I think it's quite a bunch. Yeah, unfortunately, I don't have like hard numbers here. But just to give like a rough idea, it's about, I would say, 5–15% of the sentences. Sometimes it's a bit more, sometimes it's a bit less. It also depends, of course, on the documents that get feed into the model. So if there's no relevant document that actually contains the answer, which is fed into the model, then the probability increases because the model tries to generate something based on this. And if there's no clear answer to this, it tends to hallucinate more.
Got it. So this is answered by question by J Prajapati next, right? So retrieval augmentation will work with straightforward questions like what is the place? But if questions are like reference of previous question or answers like state the second point from the above answer, it will not, will the retrieval not fail at that time? Question mark.
References of previous questions.
Mm-hmm.
Okay, yeah, this is a bit more difficult. So this is more like in a chat setting, right? I think there could also be ways to include this data. So you can imagine to just store the conversation outputs or the whole conversation in a document store, just as we saw with the external data store, say for archive documents. We can imagine something for the conversation and then access this at query time. So you would basically you would issue the search on the conversation history. How good this would work with a retriever out of the box, I'm not sure. But that's an interesting thing to try, definitely.
Yeah. I'm gonna rush through the next few. So regarding, and what is source content contained content? So what is the source content contained contradictory answers on that topic? So does your response suggest that such models are not suited for decisions or analyzing contradictory answers, such as buy and sell analysis on specific stocks and securities at any given point of time? So basically, it's like stock picking, like should someone buy or should someone sell? Can we build something like that?
Sorry to interrupt you, but my audio was very bad currently.
Yeah.
And I don't see the question. Maybe just quickly try to engage my headphone and we can continue.
Yeah.
Okay, can you quickly say something? Then I can check.
Yeah. Can you hear me?
Yeah,
okay.
Now it's better. Yeah.
Okay. It was probably my like my computer that was the issue. But I think the question as well, but I'm happy to repeat for others. So Yogesh had said, like, regarding what if the source content contain contradictory answers? So the question is, does your response suggest that such models are not suited for decisions or analyzing contradictory answers, such as buy and sell analysis on specific stocks and securities? Yeah.
Yeah, definitely. So this is also this additional flexibility that we gain with this, as we can more or less fully control how we would use the score, and yeah, coming from one score per source document, maybe we can find clever ways to deal with these situations. To be honest, we haven't thought about this before with these contradictory statements, because also in our data sets, till now, this rarely happened. So also I would first tackle this if it's really a problem.
Got it. I got a message from someone saying like there's a lot of echo in my voice. So is it better now, or?
I think it's not really better, but at least with my headphone, I have a chance to understand you. Because I'm a bit closer to you now, but I think it's still a bit problematic.
Yeah, maybe maybe we can take the question from Brenda. Thomas, if you have the screen in front of you, maybe you could read that out directly.
Yeah, I can do.
So it's like how?
So how can we use retrieval augmentation for extractive summarization, since there's no additional document that we can provide for fact check? For extractive summarization. So basically, we create a summary out of certain source documents. So then we would have these source documents too. The question now is, does this summarization relate the same to like an answer that we ask for question answering? I think it's very closely related. So as long as we know which documents get fed in, we have a chance to apply such a model. I hope I could answer this. So next one is retrieval augmentation a prerequisite for mitigating hallucinations then? I think it's the most promising currently. I wouldn't say it's the only one, and but it's certainly prerequisite if you want to dive deep into it and avoid hallucinations as much as possible, because otherwise it's as we already saw, it's very difficult to just even for humans who are experts in a certain field to state, okay, that this is a valid answer, and if you have no clue about where this information came from. Next one. Can we solve the hallucinations using correct prompt or technique like with hard prompt tuning? Example of prompt, answer the question using following context. I think this is one of the mitigation techniques. So we can say, please don't answer the question if you're not sure, basically. But you wouldn't be able to fully avoid hallucinations like this, as we saw also in the examples. So even with citations, we actually had such a prompt. We used such a prompt there. Please only answer the question if you're sure, and only based on the documents, and we still got hallucinations. So I think no, cannot fully solve it. If we could construct a comprehensive knowledge graph of a domain instead of just retrieval augmentation, then maybe we can detect hallucination and contradiction more reliably. Of course, it is not easy to build a comprehensive knowledge graph from natural language text. Yeah, I think this is the basic problem, constructing a knowledge graph. And then also, typically a knowledge graph consists of like triplets. And at some point you need to extract the triplets then from your answer and compare it to your knowledge graph. So I guess there's a lot of parts in it where things could go wrong. Starting with the completeness of your knowledge graph. What if some information is just missing? I think it could be an option, but I wouldn't see it as the most promising one. Next one. Can checking semantic similarity of the retrieved sources and the question be used to reduce hallucinations, i.e., don't attempt to answer questions if they're, oh, I think I lost it. This one was stolen from me. Okay, let's head over to the next one. If we could construct a comprehensive, knowledge graph we already had. Thank you, Mattes. I wrestle with contradictory answers in source documents often, either because the sources have different answers, fact answers, not just opinions, or because answers might change over time. If the source documents came from several decades, one might say that there are 48 states in the US, others might say there are 50 states, just an easy example. So I'm very interested in retrieval, but adding in hallucination makes me nervous. So not really a question, right?
Yeah, I think Mattes was following up with answers in the text. So that's John. John had multiple questions before.
Okay. So are there any more questions? I see a question from Belinda. At least the last sentence is a question. I work for a publisher in Germany and millions of articles. I would like to build an application using a retrieval augmentation and an LLM to e.g. augment agents in news with information and rewrite it in the style of our newspaper. For this, I would like to build the application directly into this CMS so that the editors can directly rewrite e.g. incoming EPAs using pre-built prompts. How would you go about achieving this? So I guess also this would be, it depends a bit on, it's really about the freshness of these articles, but for example, you can use filters for the date of the documents and base like a LLM retrieval-augmented QA system on this. But if I get it correctly here, it's more about rewriting things, right? But yeah, also the rewritten sentences could be tested against the source documents. I think this is, yeah. So we should be pretty flexible here also. No matter whether we are using question answering or summarization or here rewriting documents, in the end, such a hallucination detection model should work around this. But of course, we should try that out.
Yeah, maybe take the one from Yogesh next. People can't see the question, so you can read it out. So
the one from Yogesh?
Yeah.
As most non-trivial real application situations often involve reconciling of diverse, contradictory, and often opposing answers or interpretations of the same context, such as static unchanging notion of frittata versus the dynamic modeling of volatile and uncertain stock markets. It's not really a question, right?
Yeah, seems to be more of a statement.
Okay. Yeah, certainly there are. I think we had this topic now quite some time, where you have lots of changing concepts and context. I think here, yeah, the most promising way would be to get like a really good retriever that gets the documents for the right context, because otherwise I think it would be very difficult for LLMs to figure out now which kind of definition is the right one at a certain point. Of course, you can add dates like the timestamp of a definition or of a use, but certainly this will introduce some probability that the model can go wrong.
Okay, I think we can take this last one maybe and then close, you know, from which one, Alex or you guys choose?
Yeah, I think I'm not sure if it's really a question. So contradictory answers, how to handle hallucinations. Yeah, basically, I'm not sure if I fully understand it because it's more about. Okay. So maybe you can elaborate on what we mean about how to handle hallucinations and contradictory answers. So, because in the end, either it's a hallucination or not. And if you have contradictory answers inside of your source documents, then it's quite difficult, I would say.
Right. But okay, I think we're on time now anyway. So, I mean, we'll try to get in touch with people with specific questions as well. So thank you so much, everyone, for participating. And thank you so much, Thomas, for giving this presentation. And my apologies for the sound issues. So take care.
Yeah, thank you too.
Thank you very much, and see you guys later. Thank you. Bye.
Bye.